Hey guys, really quickly, I want to talk about the general form of a parabola. And I know you guys know the general form of a parabola, it's a quadratic, but just talking about switching between that and vertex form, which again, you know how to do, but it's just looks a little bit different than it did when we were doing it from the point of view of parabola from polynomials than when we're doing it from the point of view of conic sections. So just want to take a quick look at that. As usual, we're going to be completing the square. So in this case, our x term is what is squared. So on this one, we're going to want to get y and the constant to the other side. So the not squared thing and the constant will go to the other side. So it could be x, could be y. In this case, it's y that's not squared. So we're taking both of these things to the other side, and you can see that they've done that here. Then you're going to get your perfect square trinomial. So you're going to divide negative 8 by 2 to get negative 4. Negative 4 squared is 16. Adding 16 to both sides. So that simplifies here. And then we have x minus 4 squared on this side. And then on this side, we need to factor out whatever is in front of the y. Right? And that becomes your 4p. So whatever is in front of the y, you need to factor that out of everything on this side. So you end up with 28 times y plus 8. So that's your vertex form on this side. So completing the square on this side. And then on this side, you're just factoring out whatever is in front of the y after you've simplified. So you have to do this first. Complete the square first, because then you're adding something to this side, and then you just factor it out, and that is that. And they're showing you that that's 4 times 7. In other words, when you go to graph this, your p is 7. So the distance from the vertex to the focus and the directrix is 7. So yeah, so that's basically all there is to it. Yep. And then if you went ahead and graphed that, it would look like this. So you have your vertex at 4, negative 8, and p is 7. So you go up 7 to negative 1. That's your focus. Down 7 to negative 15. And here is your directrix. Something that I failed to mention in earlier videos is remember that the directrix is a line. So if you're asked to find the directrix and like state it, not just graph it, that's the equation of a line. So in this case, it'd be y equals negative 15. In the example that I graphed in the last video, it would have been x equals 1, right? Because it was a vertical line. So it would have been x equals 1. This one's y equals negative 15. So just a reminder that if you're asked to state the directrix, don't just say negative 15. The directrix is a line. So that's y equals negative 15. Okay? What else about this graph? It's opening up, which we get from the fact that x is what is squared and the thing in front of the y is positive. This distance is going to be 14, right? It's going to be 2 times p. P is 7. So this distance is going to be 14. So we're adding 14 to 4, and that gives us this 18. Subtracting 14 from 4. So that gives us the negative 10 here. And then we just graph it. Okay? Hopefully that helps, and I will see you guys in the next video.